All right, guys, we're going to add a new tab to our notebook. So if you don't have them already printed out, it's actually listed as chapter 2 at the top of our Google Classroom classwork page. It's actually the chapter 2 one. And there's kind of a reason for that. So if we go to the end of our proof stuff, which is all the way here, 26, we're going to add this new divider. Normally I do lines and angles second because, chapter 1, where we were doing all this introductory stuff to geometry, we were talking about lines, line segments, and angles. So for me, it always just made sense to go to this topic next. But again, to be on the same page as everybody else, they normally do proofs after that. So even though we were just talking about all this stuff about reasoning and proving stuff and using deductive reasoning rather than inductive reasoning, we're going to move away from that a little bit and move back to sort of kind of algebra type stuff, but on top of shapes. So this one can go around our next page. I'm going to add a little tape here. So our next topic, we got lines and angles. So if you notice, we kind of have lots of lines crossing each other and different angles that are formed, so that's fun. And then I don't think we're going to put anything on this page right here, but let's add to our table of contents. And we're going to talk first about linear equations and graphs. So hopefully you remember last year in Algebra 1 talking a lot about graphing a line, writing the equation of a line, all that sort of thing. We're going to do like a crash course of that in like a day. It's going to be great. Okay, so this is going to be on page 27 and 28. Again, we're not going to do anything here. So we're going to turn the page. And the next thing that you should have in your notebook looks like this. We're going to actually cut this in half long ways because these two sides are the same. And then we can recycle that other half. This is going to go on, what did I just say, 27. And I think what I'm going to do is I'm going to fold down the top right here like this so that it will fit in. Is that a little glue? Should do. And then the next one we also need, so this one probably looks like this. We're just going to fold that right in half along the line to create a mini book. And then if you want to cut along each of these 3 lines to get a little door, just be careful. It didn't totally print evenly, so you can kind of see through the paper and you want to cut a little bit above those lines so it doesn't cut it off. Okay, so that's on 28. So again, for me in my brain, it just kind of flows a little bit better. Like we were talking about lines, line segments, angles, angle addition, all that stuff. Then we kind of had to go away from that and talk about how do we prove stuff to be true, which is important. But now we're going to jump back and look at those lines again. So specifically, we want to look at lines and how we write the equation of a line. And then over here, how we graph the line. Okay, so I think I actually want to start with writing an equation first. Now, when we're writing the equation of a line, we can actually write it 3 different ways. So one way to write the equation of a line, I'm going to zoom in on this just a little bit. Maybe not. Maybe not. One way to write the equation of a line is to put it in slope-intercept form, which looks like y equals mx plus b, where m is your slope, which is like rise over run. And B is your y-intercept, which is a point, 0, comma something. Okay, so that's one way to write the equation of the line. Another way, equally viable, sometimes more so, is point slope form, which looks like this, where m is still your slope, and this x1, y1 thing, those are your x and y values of a point. So this guy here, that guy there, are any old random point on the line, so x comma y, any point. This, it has to be a specific point, it has to be the y-intercept. This can be any point. So that's why this one's slightly better, because it's less specific, which makes it easier to do. The other form that I didn't include on here because nobody ever wants that form is standard form. It had the A, B, and C in it, but we don't really need that one. So I go over this first just to talk about over here. If I want to write an equation, I can write it in either one of these forms. So if I'm lucky enough that they tell me the slope and the y-intercept, then I can just plop it into slope-intercept form. So what I'm going to do, you guys, is I'm going to do half these examples, and then we're going to do the rest together in class tomorrow. So number 2, write an equation in slope-intercept form. So that means I should be writing it like y equals mx plus b of the line having the given slope and y-intercept. So they've told me that my slope is 3/4, so that will go here. They've told me my y-intercept is 3, so that will go here. And we'd write y equals 3/4 x plus 3. Bang, bang, done. That's it. Now, if they're less nice, if they don't give you the slope and the y-intercept, if they instead give you the slope and a point, so for this one we want to do y equals mx plus b. If they instead give you slope and a point, actually the better form to put it in is point slope form, because slope and a point. So I would always write this one in y minus y1 equals m parenthesis x minus x1 form. Okay, so if we try that out, write an equation in point slope form of the line having the given slope. Oh, they even tell me to. Look at that. Write an equation, but even if they don't, I would still do it. So point slope form of the given line having a given slope and contains the point. So we're going to write it y minus y sub 1 equals m parenthesis x minus x sub 1. And in place of m, I'm going to put negative 2.4. And then in place of my second y value and my second x value, I'm going to put the x and y values here. So this one's x and this one's y. So actually the y goes first. So double negative will make it a plus. And then over here when I put the 14, it's actually going to look negative because the negative was already there. Now this is a perfectly fine answer. Like you could leave your equation like this and that would be fine. I wouldn't ask you to do anything different. But sometimes it is important for us to have it in y equals mx plus b form. So this is your answer, but if we wanted to change to y equals mx plus b, we would have to do two things. We'd have to distribute, and then we'd have to move this y over, like the 12 over, so that y would be alone. So if we do that, and we distribute, we'd have negative 2.4x plus, oh my word, 2.4 times 14. I just don't know where. I'm going to have to calculate that. 14 times 2.4 is 33.6. And then I want to get y all by itself. So I would subtract 12 on both sides. Now I'm going to line it up under the 33 because that's its like term. And so then I'd have y all by itself equals negative 2.4x plus, that's going to be 21.6, which is useful because I still see my slope, still the same, but now I can see a new thing. I can see my y-intercept. So that's kind of fun. Okay. Now, if they're really not nice to you and they only give you 2 points, each one we're getting less information. They only give you 2 points. Well, you definitely have to do something first, and that is find the slope. Now, there is a formula for slope. It's like, I know you usually think of rise over run, but that means I would have to draw a picture and count it out. There's also a little formula for that where I do y minus y over x minus x. And again, I know there's the sub 1, sub 2 stuff. It really doesn't matter the order you subtract in, as long as this comes from the same point and this comes from the same point. So as long as you subtract in the same order both times. And then second, you can do whatever you want after that, but I would suggest put it in point slope form. And that's because I'll have just found my slope and I have 2 points to pick from. So I can pick either one, which is better than the y-intercept. I don't know what that is, so I don't want to put it in y equals mx plus b. So write an equation of the line through each pair of points in slope-intercept form. So they do want me to do it in slope-intercept form, but I don't have to go straight to that form. So I'm going to show you how I would do this. First of all, always got to find the slope. So we're going to do y minus y over x minus x. So I could do negative 6 minus 9, but I think it's actually smarter to go the other direction. 9 minus negative 6, because the double negatives will make it a plus. And then I would do, so since I started with this point, I have to start with the 8 minus negative 12. So again, that's kind of nice. The double negatives make it a plus. So I'll have 15 over 20, which reduces because 5 will go into both, 3 over 4. Okay, so there's my slope. Now, even though they want it in slope-intercept form, which is y equals mx plus b, I'm still going to put it in point slope form first. So I'm going to do y minus, and I'm going to pick this point just because there are no negatives involved, so I can't really goof stuff up. So we're going to do y minus that y value equals m, so 3/4, parentheses x minus that x value, so 8. Now, I can't leave it in that form because they want it in slope-intercept form, but we can do like we did the last time and distribute and then move the y value over. So if we distribute 3/4, we'll have 3/4 x minus, now 3/4 times 8, I can cross cancel and get that this is 2, and then times 3, so 6. And then I'll add the 9 both sides. So y equals 3/4 x plus 3, which again, like me personally, I'm cool with either form. Like point slope form is great. This form is good too. Feels like extra work, but sometimes it's nice to have the y-intercept. And so then last but not least on this side, if I have a graph, I could pull the 2 points off and get the slope like we did here, but we could also just do rise over run, like count it. So let me maybe get some color here so that it shows up better. You always want to start with your leftmost point, and that means I'd have to go down and then right. So when I go down, that's a negative amount, and I went down 1, 2, 3, 4, 5, 6 squares, and then I went right, which is a positive direction, 1, 2, 3 squares. So when we find our slope as rise over run, we went down 6 and right 3, which reduces to negative 2. And then if I'm able to see clearly my y-intercept, like it goes through a crosshair point, then I would just use it. Like this y-intercept seems really nice and seems to be at 0, negative 3. If it didn't go right through a crosshair, I wouldn't use y equals mx plus b. I would just use one of the 2 points that they gave to me here. So I can just quickly write this as y equals negative 2x minus 3, because that's my y-intercept. Now, just to be safe, like we could also do y minus, now this point here is at 1, 2, 3, comma, 1, 2, 3. I could put this in point slope form. So we'd have y minus y, which is 3, equals negative 2 parenthesis x minus x, which is negative 3, so plus 3. I would distribute, and I'd have y minus 3 equals negative 2x minus 6. And if I add the 3 over, I think we're going to end up at the same spot. Yep. So either way, I have the equation of the line, which is great. Okay, so we'll do the other 4 examples together. I do want to talk really quickly about graphing though. So if I'm in slope-intercept form, to graph, you first plot your y-intercept, and then you second do your slope as rise over run, and that'll get you another point. And if you remember, I can create a line once I have 2 points. So if I have 2 points, I can connect it and have a line forever with arrows on either end. Now, point slope form is a little bit trickier. You first still want to plot your point, but it's a little bit of a weirder point. It's not just on the y-axis, it's this xy value. And because of the negatives, it's opposite. So like if you look at the equation and you see y minus 2, that's really a positive 2. And if you see x plus 7, then that's really a negative 7. And then you'll second do your slope as rise over run to get your second point. So we'll do 2 quick examples. First one, let's say I needed to graph y equals 2/5 x minus 1. Whenever I give you grid lines, you should just use the grid lines. Don't make your own, like don't add in your own little tick marks. So here is my y-intercept. We want to do that first. So I plot -1 on the y-axis. And then we secondly want to count out our slope. So I'd go up 1, 2, and then right, because that is a positive 5, 1, 2, 3, 4, 5. Oops, I'm a little bit off the page. And then once I have 2 points, I can connect them to draw a line with arrows on the ends. And you could give those points name, like letters, and then you could talk about the line as like line segment AB or whatever. So cute. Okay, and then if we try one in point slope form, let's say we have y minus 2 equals 2 parenthesis x plus 1. Okay, so this one's a little bit trickier. I do need to first plot my point, which comes from here and here, and they're actually opposite. So my point is whatever is with x is the x value, but it's opposite. And whatever is with y is the y value, but it's opposite. So we need to plot that point -1, 2. And then, oops, let's make that pink. I need to do my slope, which is 2 over 1. You can always be over 1. So from here, I'd go up to positively 1. Oh, look at that. It puts me right on my y-axis. So I can now also see my y-intercept is 4. Okay, hopefully you guys kind of remember that from last year too, but we'll do some more examples together tomorrow in class, and hopefully this wasn't a forever video.